My name is Fanie Reynders. I've got a little funny name, Fanie, I get the joke. I am South African, living in Holland. I'm an architect at T-Mobile, which is a German company, so it's a whole bit weird kind of a thing. I'm a Microsoft MVP in .NET and Visual Studio. And I must say, in Roslyn, I'm not an expert. So please, if you have some feedback on what I have to share, this all the things that I'm sharing with you today is the stuff I've sort of recently found out on this cool thing called Roslyn. To the point, what is Roslyn? Now there are a few questions. What the hell is that logo? Is it the Y? Is it the N? Is it the backwards H? No one knows, right? So the questions arise on how can Roslyn help me to do the things I want to, what does it offer, and how do I use it? To answer those questions, we need to take a step back and we need to sort of think about what compilers are. Now, that is not a real compiler, that's just a black box. But in essence, compilers are fundamentally, they were black boxes back in the day, right? Now, the thing about black boxes, it gets something in, it does something, and it spits something out. And that is in essence what a role of a compiler is. It does not do anything else. So in our case, we've got a black box, we feed it an apple, right? And then we have some magic that happens inside there. In this case, it's a juggling octopus. And it spits out a banana, Crazy, right? But it's these things that we need to remember what a compiler does. Now, back in the day, when compilers just came out in Visual Studio or other IDEs, it was very tightly coupled to the IDE. We have to wait for the next version of the IDE or Visual Studio to come out to get a new version of the compiler, etc. And Roslyn's number one core mission is to open up that black boxes and to make the internals available to everyone to consume those kind of things. This is a kind of a pipeline of what a generic or a normal compiler does, the pipeline. This is not a, how can I say this? This is not always the case, but this is generically what's happening, right, inside a compiler. We have the parser, we have the symbolizer, binder, and emitter stage, whereby the parser takes the source code and it sort of parses it to a language-specific structure, like a syntax tree. Then you have a symbolizer which analyzes declarations, and it sort of also do some imported metadata. And then you have the binder that binds everything together and matches the symbols and everything, and then you have the emitter stage that emits the banana. That's what the pipeline is. Now, in the case of .NET, you will have the IL, that's the banana, right? So Roslyn follows or mirrors, in fact, the same pipeline. But it also provides a rich set of APIs for each stage. So for instance, you have the syntax tree API for your syntax. For the parser, you have this, you have the syntax tree API for the parser. For the symbols, you use the symbols API. And for the binder, you use the binder and flow API. And for the emitter, you use the IL emit API. It cannot get easier than this, right? And each API expose a set of language features. In each step, you have a formatter, outlining and colorizer for the syntax trees. Then you also have stuff like navigate to an object browser for the symbol APIs, and also another bunch of stuff for the binding, like completion, find all, rename, quick info, signature, help, etc. And then also for the IL emit, you have the edit and continue. Whoever worked with edit and continue? One person, edit and continue. Really? Must I say? I'm going to switch my demo to edit and continue. This is quite cool. Edit and continue allows you to go in live, make changes to your code, and just hit save, and it will just recompile in the background without you stopping it. That's the possibilities what you can do. Now, all this is just the compiler APIs. Roslyn is much bigger than just a compiler. It's much more than just a compiler. So the four mentioned APIs are part of the compiler APIs, which is taking an immutable snapshot of a single invocation of a compiler. And it includes APIs for C#, VB, and I think F# as well. And there are no dependencies on Visual Studio at all, or Visual Studio Code for that matter. What does Roslyn offers more? Well, in this case, Roslyn has diagnostic APIs and also scripting APIs and workspace APIs. For instance, diagnostic APIs, we can identify issues in the source and allow pluggable tools like StyleCop and FXCop to extend on that and to react on those kind of things. We have scripting APIs to allow you to run code within your application. Not compiled code, but dynamic code, like scripting kind of things. And workspace APIs are responsible for organizing artifacts in a solution, like documents, project, and a solution kind of way in one single model, so you can also work on that. So naming is hard. So initially, they have this thing, and it's awesome, and what do they name it? Well, I must say, the disclaimer, this is my theory, how it all started. Take it with a pinch of salt. And everything these days is as a service, right? So initially, there was like, juggling octopus as a service. Yo ass. Ship it. The guys came, now, you know what, actually, yeah, it sounds weird. Yoas just sounds a bit weird. This is actually a compiler, you know, like a compiler as a service. So it's a compiler platform as a service, you know. So let's just call it compiler platform as a service. V2, ship it. The guy says, yeah, no, you know what, it's not going to work for Java. It's only going to work for .NET. What do? We just add a dot. You know, we say .NET compiler as a service. And the guy came, yeah, you know what, the as a service thing is like so last year. Let's just drop the as and call it .NET Compiler Service, or .NET Compiler Platform, rather. And that's how it started. But it's called Roslyn, right? So what's the relation between .NET Compiler Platform and Roslyn? The answer is there aren't any. Roslyn is a city in the United States that was sort of, it's a code name for this product. So the official name is the .NET Compiler Platform, and the unofficial name that everyone likes is Roslyn, right? So that's the crux of it. So Roslyn is not official, but it's a cool name. It's also shorter. So Roslyn, or .NET Compiler Platform in this case, gives you the compiler, scripting, and workspace APIs. It supports C#, VB, and F#. And it has over a decade of development work in it. And it's completely open source. It gets developed out in the open. You can go and extend it and build your own stuff around it. It's absolutely amazing. And the concepts around this, if you take a look at the few concepts that are, you have got the concepts of syntax analysis and trees, which in the case of Roslyn, immutability is a thing. So you have a tree, that tree cannot be changed. You can just make a copy of another tree and replace that whole thing. That's what immutability means in Roslyn. And the syntax analysis means that you can, it takes a lexical and syntactic structure of the code into one, and it allows other tools like FXCop, like I mentioned, to sort of gain the benefits of this insights of what the structure of the code means. And it allows also tools to do awesome stuff, you know, your own tools maybe, or maybe internal tools, never knows. The semantic models are interesting because semantic models, different from the syntax tree, you've got a semantic tree, which is actually, or the semantic model rather, it's a abstraction of a language agnostic. I mean, in C# and in F# and in VB, you have a method. A method is a method is a method, right? So yeah, type is a type is a type. So it sort of abstracts everything into one kind of common model that has more, how can I say this, more intelligence on what you're actually trying to do instead of doing language-specific things. And then code analysis report on the actual state of your code at that point in time. And then workspaces, you know, like I mentioned earlier, you have, you can actually get some information about your solution in your project and your references and stuff like that. So let's say we have a syntax tree. Now, in Roslyn, there's something called high fidelity, and that means that syntax tree is built from information and it has everything it needs to recreate that source that it got. So it can regenerate the initial source. And also it has everything it needs to sort of compile, right? So each node in that tree, a tree consists of nodes, each node in that tree has a specific purpose. So if you take a look at that piece of code, class foo with a method bar, that piece of code can be dissected into a tree that looks like this, right? A tree basically is or a syntax tree rather in this case, comprises out of nodes, tokens, and trivia. The blue things are nodes. Nodes are like a sort of a grouping of things, right? So it's non-terminal things. But the green things are the tokens. That's the things that actually matter, right? It's the terminal things, and it's the smallest piece of the puzzle. And then you have the other things, which is the gray dots, that's just the enters and the white space and the tabs. Who, by the way, uses tabs or spaces? Hands up for tabs. Hands up for spaces. Dots. Come on, really? Yeah, that's interesting. 50-50. Always a struggle. And then inside a syntax tree, there's also a thing called span. Now, span is the location of each item or this thing. It can identify in your code a start and stop. So it's a location. In Visual Studio, you might have seen these squigglies. Now, this squiggly is drawn on top of a span. It has a start and a stop, so it knows where to draw the squiggly, right? And then there's something called kinds, which is language specific. So if you're working in a syntax tree, you can have a specific kind of type that's normally C# specific or F# specific or VB specific. Here's an example of what the syntax tree looks like in Visual Studio. If you install the compiler platform SDK inside Visual Studio, and you go to, I think it's View, Other Windows, and you go to Syntax Visualizer, in your piece of code, wherever you click, on the right-hand side, you will see there is a syntax tree that gets drawn up. This is your friend when you're doing code analyzers and almost said hot fixes, code analyzers and code fix providers. It gives you all the information you need to sort of discover where in the piece of code that you want to solve a problem, how is it structured, so you can use Roslyn, navigate the tree, and get insights out of the tree. And the full span is also listed there. So 0 to 6 characters is that full span, for instance. And there's even a better view. If you right-click on any node, you can say, view my graph, my syntax graph, and it gives you a beautiful representation of what your code looks like, from our overview. You can move it around, you can zoom in and out. This doesn't work in VS 2019, it crashes. I've already logged the bug, but it's quite cool. So 2017 for now, it's kind of working. Now the semantic model, like I said, it gives you information on symbols at a specific location, and the results of any expression they expose. And all diagnostics and information, the variable flow, and answers to all the speculative questions, all those things you can find in the semantic model. Who has ever seen this little light bulb in Visual Studio? Hands? Pretty much everyone, right? So this is the back of this is Roslyn, right? So it features its diagnostics, code fix providers, refactoring, and code generations. That's what a light bulb does. Now, it's not a ReSharper thing in this case. In this case, it's a Visual Studio thing, So if we take, for instance, this piece of code, the static void foo, and we have a bar, that's null. What we can do is we can have an analyzer. If we throw an argument not null exception and specify the argument as a magic string as bar, we want our code fix or our analyzer to say, you know what, there's magic strings here. Bar is supposed to be name of bar. And then we can use a code fix provider or a trigger code fix. When you click on that light bulb, it can pop up with a menu says use name of instead, and it will change your code for you. And you can do this code change per solution, per project, or only in this document. This is where the workspace things come into play. So without any further ado, I'm just going to do a bit of a demo here. See if this works. No, this doesn't work. I have to... this always happens. So let's see if this works now. Yes, looks like it's working. All right, so this is Visual Studio, and like I said, if you have the .NET compiler platform installed, you can you can have this templates. So remember, for what we're going to be doing now is we're going to do a analyzer that that's I can actually show you analyzer that that takes this function, the bar, and then we want a squiggly line there at the bar and change it to a name of. Right, so there are many ways of doing this. For now, I'm just going to do a .NET Standard Code refactoring, .NET Standard Code Analyzer for .NET for C#, for instance. And here we can do like Riga, I don't know, Riga Analyzer. I'm very bad at coding in front of people, right? So if I'm too slow or too fast, just raise your hand and I'll type even slower, you know? Okay, so now what this thing will do, it will basically spit out a few things, a template and those kind of things, but for this purpose of this demo, I'm literally going to delete most of it. You know, I'm going to start from scratch, and I'm going to show you how easy it is to actually start from scratch, given the 30 minutes I've got, or 20 minutes I've got left. So that gives me 10 minutes of demo, so let's see how it goes. Okay, so what we want is we want to add a new class, and we'll call this a awesome analyzer. Now, the one thing you need to do when you're doing an analyzer, a diagnostic analyzer, you have to do a diagnostic descriptor. Descriptor. There we go. Diagnostic descriptor. It's diagnostic analyzer. I can do that. I can control dot that out, and then language names. We're going to make this language for C#. So we go language names.C#. So that's how you sort of define what a diagnostic analyzer look like. And then, of course, you have to sort of also inherit from a base class. In my opinion, this is a bit verbose. So you could have just created one base class with the annotation already on it. But in any case, that's just me. Okay, so now it gets a squiggly line. It wants us to implement a few stuff. Let me say, okay, great. So to implement a diagnostic analyzer, by the way, we need to have a supported diagnostics, which is a list of diagnostics that this thing supports, and also initialize method that Visual Studio will call into to say, you know what, this is my context. Let's initialize this to register your diagnostic. So what we'll do is we'll get rid of that for now. Well, first, I think what we can do is we can create a new private static diagnostic descriptor. That describes the rule. So we can say this is a new diagnostic descriptor, and we can give it an ID. So in this case, we'll give it an ID as a name of Awesome Analyzer. And what else does it need? It needs a title. So in our case, it's for instance, argument as magic string. And then what else? We have description. Let's just say argument whatever, which is that, is a magic string. Consider using name of. All right, so, and then other one what we need is a category, so we just call this naming. And then the last one is, oh, that's not last one, it's default severity, so we'll go default severity, diagnostic severity. You can either have it as error, hidden, or info or warning. Error means it will actually break the build, so you can actually stop a build from happening. But we'll go for warning. It will just say, you know what, by the way, you might want to do this. It's not wrong, but it's not right either. And then the last thing is we want to enable this by default, so we'll just go true. That's pretty much it, right? Okay, so now supported diagnostics, we want to actually say, you know what, I'm going to create a new immutable array, immutable array.create, and I want to give it a name of, or no, I actually want to give it the rule. This is an array of this rule, so only these rules are kind of supported. You guys can see the text, right? So I would just like hear someone shout, I can't see. So I'll zoom in. All right, so now to register it, it's pretty simple. You just go context dot register, and I think it is register syntax factory or something. Register syntax, register syntax node action. And then here we'll just pass in a function, which we'll write now. So analyze node or something. And then we'll give it a syntax kind, which is kind of a filter. Instead of, it will throw all the registrations, it will only register for specific ones. So in our case, we want to register for instance, the syntax kind for, that. Syntax kind. Is that popping up? Yeah. For argument. Okay, so to basically show what I mean is, if we go to View, any other windows, you go to Syntax Visualizer, where I click, if I click all around, you see what happens here on the right-hand side here. So if I can just maybe dock this guy there, if I click there again, this is a string literal expression, which is under the string literal expression node. Its parent is our argument. So we want that argument. And as you click around, you will see the thing highlighting. So we'll go for that argument and grab that argument. And we want to analyze that argument, whether it contains a string literal expression. And if it's a string that matches the one of the parameters in the parent somewhere as a parameter, it should flag it, right? So easy as that. So let's do that. Right, so let's implement this by just control dot. We just control dot our lives. So we just go control dot the whole time. That's how we code. You only need one. You only need two keypads on your laptop. It's control and dot, and sometimes space and tabs for the tab guys. All right, so let's see. We pass in the context. So first of all, let's grab the argument. So in this case, we say, it's the context node. But node is a type of syntax node. But we know already that the syntax kind is argument filtered already. So we can immediately cast this to a argument syntax. Oh, not argument exception, syntax. Control dot, there we go. So now we know argument is an argument syntax, right? Now we're going to go a step further. And we can say, argument expression is kind, or not is missing, is kind of a syntax kind. Is it a string literal expression? Right, so if it is a string literal expression, we can go further and say, get me that string literal expression. So we can go string literal, and that is the argument's expression. And we can just maybe cast that, to a literal expression syntax. See how you go on. You point and you say, oh, actually this is this, and then you cast back to that one, and you have a more strongly typed way of working with these kind of things. All right, so now we need the text. We go, give me the text of the string literal, give me the token, which is the actual thing that matters, right? Give me the value text of that. So going back to my demo, or to my sample, I'm talking about that guy. That's the actual value. So if you go down here, bar is the value, the bottom there, bar is the actual value text that I'm actually going to get. All right. Okay, now we need some kind of way of sort of getting the parameters in some kind of parent function. So for that, we'll just do parameters, and we'll say get parameters. This is a function I will write now. We'll give it an argument, for instance. Maybe I'll just implement it quickly. I've got a code snippet here that does that. In case of for time, I will just implement it here. We will go through that in a second, what it does. Something is not right completely, no. Let's just do this. There we go. That's much better. All right. So we have the parameters miraculously. We got it. And then all that we need to do is we need to say, if my parameters that I get back, if any of those, which is control.link in here, if any of those have a identifier with a value text equal to the text I want, for instance, I'm there, right? So then I can say, you know what, this is a flag. So now I need to say, you know, I want to create I want to raise this report and say, you know what, this is wrong. Let's create a diagnostic. And we say, you know, diagnostic factory, which is diagnostic.create. And we pass in the rule, you know, that we've defined on top. We give it a location. So the location is the string literal dot get location, I think. Yeah, get location. We give it a message argument. You know, in the message, you need to give it an argument to sort of say, this is wrong. So in this case, it's text. And that's it. So that's our diagnostic, and all that we need now to do is report it. So we go context.report diagnostic. And we throw in the diagnostic in there. So that should be enough to kind of report any problems in the source code. In terms of this get parameters thing, all that this is doing, it's getting in a argument syntax, which is a syntax node, really, and it's looping it's looping in this argument. For each parent, you know, it's getting the ancestors and itself. So it's looping through all those nodes, and then it's checking, is it a method? So I'm looking for a method all the way up to the tree. I'm looking for a method. If I find a method, then I grab the method, I cast it to a method declaration syntax. Then I want to grab the parameter list. And I go through the parameter list and I go, you know what, you know, just yield return me the parameters in a parameter syntax list. Easy, right? So let's see if this works. So, by the way, there are two ways of shipping analyzers. You can do it via NuGet packages or via Visual Studio. If it's via Visual Studio, every project that is going to be working with this, or every project that you're going to be opening up with Visual Studio will be affected by this analyzer. If it's a NuGet package, it's more project specific. And both has its pros and cons. So in this case, for the sake of time, I'm just going to be using a demo instance of Visual Studio, and I'm going to be running the VisX, which is the extensible project, just to test it. So this will actually now spawn up a new instance of Visual Studio, and it will sort of inject my analyzer on an extension level, and hopefully this will work. So it takes a bit of patience, so just bear with me. Don't have the most powerful machine. I have to sort of I had to spin up an Azure VM for this, for the sake of this, but because I don't know my laptop will do its job properly. But in any case, so let's see what happens. In a sec, you will see a Visual Studio spin up, and this is pretty much Visual Studio as we know it, right? With all these other things these black things that's up there. So let's open up that console app that we have earlier. Our test. And then it's always infinite in these kind of things, you know. With what takes 3 seconds during preparation takes 3 hours on stage. You know, it's always like this. It's prepping the solution, doing these kind of funny things. This is, by the way, one of the cons of developing VisXs. You have to sort of wait for Visual Studio to start up and all that kind of things. So now it's loaded the project, and it's sort of figuring out there's no issues found. And then in a second, it will now start to highlight, hopefully, that bar. Does this work? Plus, yeah, that bar has a squiggly line, right? So that's pretty cool. So we have a light bulb, but the light bulb won't do anything yet because we don't have a code fix provider for it. So how this works is a diagnostic can live on its own, but a code fix provider cannot live on its own. So a code fix provider is dependent on a diagnostic. So for us to take this further, or a step further, we now need to do a code fix to fix this problem. The control dot, that thing, right? So let's go back. So we know the first part of the demo works, so that's fine. I can earn my first beer, which is amazing. And we have to close down, and then now let's see what's next. So let me see here. Okay, so we need to also create another class. because it's a totally different concept. The code fix providers are totally different concepts. It provides a code fix upon a diagnostic. So let's call this awesome code fix. And yet again, same pattern goes. We have to say, attribute exported code fix provider, not presider, but provider. Yeah, look at that. Exported code fix provider, and it actually suggested the right name, which is quite cool. This is also a Roslyn thing, by the way. Export, so it should be there. Okay, I want that one. Obviously, I can't spell. So we go language names, control dot, C#. And also, lo and behold, I need to do this again, which I don't really like, but fine. We have to do like a code fix provider base class. And again, it will allow us to sort of override or implement the overridables. Now, yet again, what diagnostics can this code fix provider solve? Well, in our case, it turns out that it's a string of array or an immutable array, so it's just the names of diagnostics. So what we can do is we can go immutable array dot create, and we say this is specifically for a name of awesome analyzer, right? So now I have an array of strings, which is the awesome analyzer's text. In this case, when you control dot, when it builds up the menu, it kind of registers, oh, I need to do something now. Let's build my menu and see what I can provide. In this case, it can now sort of call this function. So what we need here is we need a root, and actually we need to sort of await this, async this, because we're going to be saying, context, give me your document, and get me my syntax root. You know, the root of the syntax. And for this, we just pass in the context cancellation token for some reason. And then we grab the diagnostic. Context dot, I think it's diagnostics dot first. First is not available, just control link in there. So we'll just grab the first diagnostics that is available in this case, and now we want that span, you know, that squiggly line. We want that part of the code that we can analyze further. Grab the span, we say diagnostic dot, I think it's location dot source span. All right, so I think we've got everything we need now. Now, to move on, we need to get the string declaration. So we say, you know, var string declaration. That's the root. Give me my token. Is this now? What? I am not in. Oh wait, there we go. Thank you, sir. Did all this in sync but not using it. Oh my gosh. Let me see. What do I need here? Find token. And I want to find it from the span.start. And I actually not want the token, I actually want the node. So I'm going to go parent, which is the syntax node, because I'm going to work with the node instead. And then when I have the parent, I want to get the ancestors in self, and I want of type, and guess what? It was the literal string expression, or literal expression string, which is not right. Literal, also not right. Literal expression syntax. I can't type. There we go. So now I know when I move up into the stack, I will only find the string declarations of type literal string expressions, you know, inside a method. But I only want the first one. Okay, great, for this example. Yeah. So the last step of the puzzle is to go, you know, context.register code fix. And for this, I will make use of some factories. Number one, I'm going to be going to use a code action. dot create, and I'm going to pass a few things in here. Title. The title I'm going to name this name of I don't know. Oh, actually, the title of this syntax. Let's call the title use name. No, not like. Let's go like this. Name of like this. I think that's fine. That's the title of the item in the menu that you want to show. And we want to trigger this when we actually want to provide it when a document is going to change. So we're going to say create change document. So I'm going to change my document with this code fix. For that, I'm passing a token. Oh, not that, a token. And I'm going to be using a name of function that I'll be writing soon. I'm going to be passing in a document and my string declaration and my token, cancellation token. And that is it. Just have to close those brackets, and that's fine. And all I need to do here, everything is not fine. I still need to give back diagnostic. So I'll just pass in that diagnostic so that I can marry the code fix with the diagnostic actually here. Now I need to sort of generate my method for my name of. Let me see, do I have everything here? Yes, I do. So now what I'm going to be doing is I'm going to be doing a lot of factory stuff. So I'll be using C#, I think it's 5 or 6 static usings. So go system.codeanalysis or Microsoft.codeanalysis. Codeanalysis. I think it's C# .syntax factory. Syntax factory, right? So I'm using this static. So this allows me to sort of just, instead of using syntax factory the whole time, I can just like use the functions within it because it's already imported. Also keeps the code a bit more clean, you know. All right, so I said earlier, immutability is a big thing in Roslyn. You can't just go old document, new document, old document is equal new document, or new document is equal old document. You know, equals does not work. You have to recreate that document from scratch. And to do that, you need to figure out what the old document is, get its root, modify the nodes, get the new syntax root, apply that syntax root to the new document, and pass that new document back. So it's a whole big thing, but Roslyn comes in with these factories to sort of save the day. So what we can do is we can go old document is a document, right? So it's the document that we want to pass in. That's the first document. So we can go old syntax root. Actually want to async this. Await, get my old document, get syntax root. I want to pass in my token that I might receive. And I want to get my old node, which is the string declaration. Old node is the string declaration. There we go. So now what we need to do is we need to figure out a way of, you know, creating an invocation expression, which is the name of, and we need to give the invocation expression some parameters. Parameters is a list of parameters ideally. So in our case, it's just one. But we need to create a list with one inside there. So for this, we'll just create var new arguments. And we'll go old syntax root. Oh, actually, we'll create a single separated list, which is a single list. Doesn't really make sense, but fine. Then inside there, we'll create an argument. And inside the argument, we'll create an identifier name. And the identifier name is old node, I believe, old node. Did I say old name? Old name, cool. Old node, let me see, dot token, dot value text. Now I have my arguments, which is a list of argument which has identifier, which is the old node's token name, or token value. Now let's create our new node. It's an invocation expression. Invocation expression, and it includes two things. We need to give it a identifier name. In this case, we want to have a invocation of nameOf. That's the function, or that keyword rather. And also we have our argument list. And guess what? We have an argument list, so we can go new arguments. Pass it in there. That is it. So all that's now left to do is, now we have our new node, let's create a new syntax root. It's all syntax root dot replace node, and we give it an old node and a new node. That's fine. Now we have the new syntax root. Now we can go var new document, and we say, all document dot with syntax node, or with syntax root, and give it a new syntax root. And now we have a completely new document, and all that we can do now is, return the new document. And if everything allows me, then it should work fine, right? So after a quick compile, everything looks fine. Yeah, that's fine. Let's quickly run it and see what happens. Got like 7 minutes left. We'll see what happens. Loading up the solution, preparing the files, blah, blah, blah. This is some of the frustrating things you have to deal with Roslyn. Should actually show you how you just pack it as a NuGet package, and then you can just ship it as a NuGet package. By the way, this works in VS Code now. If there's time left, I can show you how to do that. This is the same experience. If you ship that analyzer class library as a NuGet package, just pack it, and it will automatically install that into your project as an analyzer, so it can run on Visual Studio Code or any other IDE. Preparing the solution, let's see what happens. So now we have the bar. We know the sort of light bulb works, right? So that's not a thing that's hopefully not going away. After a while, when the thing loads up and it says there are any issues, in this case it says, okay, you know what, I've got one issue, that's fine. Now let's control dot. It does not work. So for some reason, actually this whole thing, I've got some problems with Visual Studio, that for the second time around, it does not register my the new version. So what I normally tend to do is I just go in here and I'll just up the version with 1 dot, and this is the issue. I don't know if it's an issue in 2017. Never had this issue. It does not replace that version. Although it's a new version, it does not replace that version. So it has some kind of cache mechanism. So it does not update it does not know about my code fix. In this case, you won't get that code fix from my light bulb. So hopefully this will work. It seems faster. So let's see what happens. Loading a project 0 of 1. Luckily, I don't have 50,000 projects, right? Think about that when you're doing analyzers. Do the filtering, that matters. And we go on. It's preparing the solution. Let's wait a while. We've got plenty of time left. All right, so let's see if this works. Eventually, it will start to light up. And then we have some coloring, which is fine. There we go. And then we see control dot. Use nameOf. And there's the nameOf thing. So now if I go use nameOf, it changes that to use nameOf bar. If you could have followed, that's fine. I will see if I can get the sample up onto GitHub. But in essence, that's all. That's really that that's all to it, really, you know. Let me see if I can grab VS Code quickly. VS, or actually Code. Got like 4 minutes left, which is fine. And what I want to do is I actually want to package this as a NuGet package. And I already have it set up somewhere, so I can go, you know, bin, debug. We all do it in debug, which is fine. I'll just drop everything, not IE. I want drop everything in my local NuGet repo that I have here. Let's go in there. And then we say, you know what, let's open up VS Code. And yeah, the same thing happens here, right? So let's see if this works. So first, let's call this var. And then this won't work because I still need to add this this package here. So I think you need to add a, is it an item group or something? Let's just add it in Visual Studio because I cannot type right now. Dependencies.add, manage NuGet packages. Oh, not this one. I'm just adding the NuGet package reference to this thing. Updates, browse. There we go. That one. Install that one. Yes, whatever. So now I'm shipping my analyzer with my project. So wherever that project goes, my analyzers ship with it. I go here. I can just actually can this. It's not needed. See if that's been updated. No. Restore complete. Now that's concerning because it's not the right solution. Is it? Yeah, there we go. So now when I do this and I go do a quick .NET restore, does not work for some reason. Let's exit and go in. Maybe that's that code. And for some reason this doesn't work. It's loading, preparing symbols. That was the version of the VisX. This is the version of the NuGet package. It's different. So yeah, there we go. There's a problem, light bulb, control dot, use name off. Done. It works everywhere, right? So it's not a what do you call it? It's not a legend. Right, so quickly. You can do, of course, many other things with this thing. Here I've got a recording of, HTTP client. If you're instantiating HTTP client as new HTTP client or doing it in using, you're doing it wrong. You have to do either a static HTTP client or make use of the client factory. This way, Roslyn can help us and guide us doing instantiating HTTP client factory much better. So this is just a little video I've tweeted a while ago. Little helper that will allow us to sort of stop bad developers doing bad things or naughty things in our code bases. Right, in summary, Roslyn exposes rich APIs. It's got a full fidelity of .NET stuff. It enables innovation, it enforces standards, and it provides guidance. These are my contact details. Thank you guys very much for listening, and enjoy your day further, and enjoy the beers. I'll be around. Thank you.